Hello everyone, let's talk about another medium problem on Leetcode today, palindrome partitioning, Leetcode 131. In this, we are given a string S and we have to partition a string such that substring of the partition is a palindrome. Return all the possible palindrome partitioning of the string S. So then they have given the example as well. So they have given example as well. Example 1 is input S is equal to AAB, and then we get two partitions as an answer. So one is AAB and AAB, yeah, so three characters here, and then here two strings again. And then they have given example 2 as well, where all the input is A and then we get output also as A. So notice that all the outputs are like palindrome. So A is also a palindrome. And what this problem covers is, like, first thing is we need to return the substring. So that means the string has to be contiguous. And second thing is it's just partitioned. So if we draw it out, then we can see that, okay, so this one is A, right? A, B. So it's partitioned like this, right? And second second output is like A, B. So these are also partitioned, right? So these are the two outputs we return. Now we jump into the solution space. So again, similar to the subsets problem, we have to return the actual output, right? We have to generate the partitions and add and return those partitions. We don't have to return maximum or minimum or those kind of things. So I think the important thing is, like, we have to use backtracking again. That is, like, we have to do brute force way of going to the different paths and backtrack. So I have drawn this tree so that you don't have to look at my bad handwriting. So for example, our input string is AAB. So we can take first character, say A here, right? Then we go deeper, right? The remaining character is A again. So this is a palindrome. This is also a palindrome because single character in itself is a palindrome, right? And then B. So all of them are palindromes. So we got one of the answer. Now we backtrack, right? And we come to this A, and we go to the remaining string, which is AB. And this time when we go there, we see that, okay, AB is not a palindrome. So we backtrack, we come to the root node again. This time we take two characters at a time, right? So this will be AA, right? And then remaining character is B. So AA is palindrome and B is also palindrome, and we have reached the end of the string. So this is also one of our answers. And then we backtrack and come to this solution AAB, and this whole string is not a palindrome at all. So I hope this logic or this backtracking state space tree is clear to you. Now let's jump into the code part. Now in terms of solution, we just need answer variable, right? Then we will check if for us if the string is, I mean, they have given that string is not null, and it will at least have one character. So I will skip it. Otherwise, what if interviewer says that string can be empty, then it's good to ask those kind of edge cases. So we will just return what is the answer here. Of course, in our case, the constraint says that this will not happen. And finally, we will just do the DFS. It will be very similar to the subset sum problem. So we start with the 0th index and pass in one of the partitions, right, or sub answer, and then the whole holistic answer which we will return, and that's it. I think this is the initiating part. Now let's jump into the DFS part. So what we will do is, like, we will just say DFS, and again, first thing is our string S. I mean, that's why sometimes I like Python, that because you can write like a nested function and you don't have to pass these variables again and again. But here we are. So we do list of string as sub answer, and then in Java, I think we can also define them at the solution or the class level. Then we as an attribute or something, so we don't have to worry about it. And then we just pass list of string as answer. Yeah, that's it. Now first condition is if we have reached the base condition, that is we have touched the length of the string, because it should be index should be within 0 to n minus 1, not at n. So we will just return the answer. Sorry, we will just return, but we will, before that, we will add our one of the partitions. So we will say okay, and we will add sub answer here. We have to note that we are doing new array list because sub answer will always be mutable, and we have to make sure that when we backtrack or we do the modification, we still have our answers intact. So that's why we do the deep copy. And once we do that, then we just do the DFS, or the backtracking that we did in subsets. So first thing we will do is we will create substring of size I plus 1 from the index point, right? And check if it's a palindrome or not. We already covered this problem today, where we give an input string, check if it's a palindrome or not. So we will just do that. So if is palindrome, right, then what we have to do is like we will continue down that path. So we will just say subanswer dot add current string, right? And then we do the DFS and go to the next character. Like after A, we in this example, after A, we again go to the A part, right? So that we will do it by going to the next index, pass on the sub answer because we have added A to it, and now answer. After this, I think we have to also revert, because remember, after backtracking, we also come to the part where after adding A, we also want to add AB. So it will be sub answer dot remove, because we added it at the end. So we know what's us how to remove it by using the size, because that was the last element that was added. And once this is done, we are also kind of done. So we will just return back, which is still remaining is we need to write is palindrome, right? And what we have to do is like we start with left equal to 0 and right equal to s dot length minus 1. And then what we have to do is we will just do while L is less than right. Now we will use a two-pointer approach, and if s dot char at L is not equal to s dot char at R, we will just return back as quickly as possible. So we will return false. Otherwise, we will just do L plus plus R minus minus. And if we reach the end of the loop, that means it was a palindrome, and we will just return. Now let's submit this code. Awesome. Let's submit this code now. Cool. It was not that slow. I also tried adding like caching to the solution for the palindrome, because we are calculating the palindrome again and again. But unfortunately, the input was such that caching was making it worse. So I will always ask the interviewer if the input is like that, and then only do it. Now let's jump into the time complexity part. So as you can see, like at each step, we are breaking down the string into like two decisions, like whether we take it or not. So at the top level, there are n strings, n substrings, right? Of what you say, different length from 1 to n, right? And then for that, we take a decision whether to take the string or not. And that will take like n into 2 to the power of n. So that's the time complexity. I hope this helped you, and if it did, please like and subscribe and share it with your friends, and please let me know how I can do better. Also, the code link is in the description. Thanks again. Have a nice time.